In order to solve an equation that contains a single trig function, step one is to get that trig function by itself. So let's begin by moving over the square root of 3. So let's subtract root 3 from both sides, followed by dividing both sides by 2. Now we want to remember that on a unit circle, all points that are on the unit circle are the cosine of theta, comma, the sine of theta. So what this really means is what angle measure has a y-coordinate of negative root 3 over 2. So take a look on your unit circle, looking for where the y-coordinate is the square root of negative square root of 3 over 2, and that happens here at 5 pi over 3. That's also going to happen here at 4 pi over 3. So these are my two solutions on the interval 0 to 2 pi. Now if you have the trig functions, sine or cosine, it's pretty straightforward, because once you get to this step, if it's sine of theta, you're just looking for the y-coordinate, what angle measure gives you this y-coordinate, and if it's the cosine of theta, you're looking for what angle measure has an x-coordinate of what's sitting there. Then we'll look a little bit more here at tangent, but in general, just a general rule, if your trig function is something other than sine, cosine, or tangent, I typically turn it into one of those three because it's just easier to look on your unit circle. So here's an example of that. I have the secant of theta. So I'm going to start off by getting the secant of theta by itself by adding 4 to both sides and then dividing by the square root of 3. Now I don't prefer to work with secant, cosecant, or cotangent, so I can quickly turn secant into cosine because the reciprocal function of secant is cosine. So I'm going to say this is cosine of theta by setting this equal to the reciprocal. If this would have been cosecant of theta, then I would have had the sine of theta by flipping that over. And if this would have been cotangent of theta, then I would have the tangent of theta by flipping that over. Okay, so now all I need to do is look on my unit circle, cosine comma sine, for what angle measures give me an x-coordinate of root 3 over 2. Okay, so let's take a look. And that's going to happen at both pi over 6 and 11 pi over 6, because again, the x coordinates are positive root 3 over 2 at those two locations. Now this one, the cotangent of theta, the good thing is the cotangent is already by itself. But I personally don't care to work with cotangent, so I'm going to turn that into its reciprocal function, tangent. So I've got the tangent of theta equals, and I've done that by taking the reciprocal of the square root of 3. Okay, then the next thing to know is I should back up for 1 second, sorry. So I went ahead and rationalized this by multiplying the top and the bottom by the square root of 3. So root 3 times root 3 is 3, and 1 times root 3 is root 3. Okay, so tangent is the y-coordinate on the unit circle divided by the x-coordinate. So if I go looking around the unit circle for where does the y-coordinate divided by the x-coordinate equal positive root 3 over 3. Now that can take a little while if you use this method, but if I start going through looking, I'm going to find out that happens at both pi over 6 and 7 pi over 6. At pi over 6, for example, I'd be taking 1/2 divided by the square root of 3 over 2, and that gives me root 3 over 3. And then the same thing there at 7 pi over 6. But another way to think about tangent is to just simply understand the meaning of tangent, its slope, y over x. If I want to know the tangent, like where is tangent of theta equal to 0? Well, right here, the slope of the line is 0. So at 0, the tangent of theta equals 0. Right here, the tangent of theta is undefined because the slope is undefined. Right there, the tangent of theta equals 0 because the slope is 0. And here, the tangent of theta equals undefined because the slope is undefined. Okay, then a couple other obvious ones looking at slope. When I go through this red dot here at pi over 4, the slope of that line is 1. So tangent of theta is equal to 1 here, and it's also equal to 1 here. And then the tangent of theta equals -1. Here I'm making a line that has a negative slope. And so right here at 3 pi over 4, the tangent of theta equals -1, and the tangent of theta equals -1 also at 7 pi over 4. Then by process of elimination, what I like to do, instead of again going through and dividing the y coordinates by the x coordinates, is what is square root of 3 over 3 approximately? Okay, well, if I divide root 3 by 3, I get 0.58. So if that is slope, think about slopes. If this here is a slope of 1, if it gets steeper, then we have a slope more than 1. If it gets less steep, we have a slope less than 1. We want a slope that is less than 1. So it can't be through the red dot because that's a slope of 1. So if it's a little bit less steep, it's right there, which happens to be at pi over 6. And then over here, again, going through the red dot, that's a positive slope, slope of 1. And if I want a slope of 0.58, I need that to be a little less steep. So moving to the blue dot here at 7 pi over 6, that's a little less steep. And so that happens to be where the tangent of theta is 0.58. If we would have the tangent of theta equals a negative number, I'd look here and here. Oh wait, negative number, negative slope is here, negative slope is here. So I'd be looking in these two quadrants. If tangent of theta is a positive, I'm looking in these two quadrants. If the tangent is equal to 1, I know I'm right in between, a little more than 1. It's going to go up to here. A tangent of theta equals something a little less than 1 there. So using the idea that tangent is slope is a little faster than going around your unit circle looking for where does y divided by x equal this value right here.